What is game theory? It can be defined as the study of mathematical models of conflict and cooperation between intelligent rational decision makers. It provides general mathematical techniques for analyzing situations in which two or more individuals make decisions that will influence one another's welfare. It offers insights of fundamental importance for scholars in all branches of the social sciences as well as for practical decision makers.
Game theory is first mentioned in a letter written in 1713 by Charles Waldegrave, which provides a minimax mixed strategy solution to a two-person version of the card game Le Heur. This problem is now known as the Waldegrave problem. 200 years on, Ernst Zermelo published a paper which ultimately proved that the optimal chess strategy is strictly determined. Game theory did not really exist as a unique field until 1928 when John von Neumann published a paper in which his original proof became a standard method in game theory and mathematical economics. During the following time period, work on game theory was primarily focused on cooperative game theory, which analyzes optimal strategies for groups or of individuals. Then in 1938, mathematical economist Frederick Zeuthen used Brouwer's fixed-point theorem to prove that the mathematical model had a winning strategy. The first time a mathematical discussion of the prisoner's dilemma occurred in 1950, and an experiment was undertaken as part of the RAND Corporation's investigation into game theory. RAND pursued the studies because of possible applications to global nuclear strategy. Game theory experienced a flurry of activity in the 1950s, during which time the concepts of the core, the extensive form game, fictitious play, repeated games, and the shapely values were developed. In addition, the first applications of game theory to philosophy and political science occurred during this time.
Game theory is the study of how people and businesses behave in strategic situations. There are various types of games that might be studied. Simultaneous game. The player effectively make decision at the time. They don't know the choice of other players when making their choice. Secondly, sequential game. A sequential game is one in which players take alternate turns to make their choice. One-shot game. This is a game that played only once. In one-shot reaction, people often have incentive to behave opportunities or selfishly. Repeated game. A very common feature of applied business. For example, decision on pricing establishes supermarkets versus deep discounters, the size of marketing budget, such as Coca-Cola vs Pepsi.
The Prisoner's Dilemma. This is a classic example of a game which can be analysed through game theory. The game is hypothetical where there are two people who have committed a crime and have been arrested. They both have two options, which are to cooperate or defect. If they both cooperate, they will spend between them less time in prison. However, they can always better their own situation by defecting. But if one person defects and the other one cooperates, that means one person is going to prison for 3 years and the other one is getting away for free. It's risky defecting, as if they both defect, they're both going to prison and for the longest overall time, 2 years each. The game assumes the players are rational agents, which means they always pick the option to benefit themselves. Situations like this in the real world have more factors in play. For example, players can get to build a relationship and work together to gain an advantage over time. In the real world, this could be two companies which have closely related products who are deciding whether or not to run an advertising campaign. Depending on what a company chooses, it can directly affect the other company's choice. However, these companies can build a relationship in which they pick a situation where they both agree on and prosper from.
As a method of applied mathematics, game theory has been used to study a wide variety of human and animal behaviors. It was initially developed in economics to understand a large collection of economic behaviors, including behaviors of firms, markets, and consumers. Over time, the use of game theory in the social sciences has expanded, and game theory has been applied to political, sociological, and psychological behaviors as well. In addition to being used to describe, predict, and explain behavior, game theory has also been used to develop theories of ethical or normative behavior and to prescribe such behavior. The definition of description and modeling method is basically in the name. It's used to describe and model how human populations behave. Some scholars believe that by finding the equilibria of games, they can predict how actual human populations will behave when confronted with situations similar to the game being studied. This particular view of game theory has been criticized. It is argued that by assumptions made by game theorists are often violated when applied to real-world situations. Game theorists usually assume players act rationally, but in practice, human behavior often deviates from this model. In political sciences, game theory could help predict a nation's response when there is a new rule or law to be applied to that nation. In computer science, several logical theories have a basis in game semantics. In addition, computer scientists have used games to model interactive computations.
The importance of game theory is to make the best decision. As humans, we do not always make the best decisions or act in the best interest of others, since we aren't always rational. Therefore, the theoretical modules can help us to conclude a rational decision. It also helps us to analyze the situation more rationally and develop effective plan based on the situation. The result of this will either be true or false. Finally, it helps us to solve certain economic problems, which involve risk and technical relations. They can be handled with help of the mathematical theory of the games. Problems of linear programming and activity analysis can provide the main basis of economical application of the game theories.
Limitation of game theory. As the number of players increases in the actual business, the game theory becomes more difficult. However, the theory of game has not been developed with more than 4 players. Most economic problems involve many players. For instance, the number of sellers and buyers is quite large in monopolistic competition. And the assumption that each player knows his own payoff, but the payoff of opponent is not practical. In business, an entrepreneur is not fully aware of the strategies available to him, much less those available to his rival. He can only have a guess of his and his rival's strategies. Humans can be strategically irrational, and in the game theory, players are assumed equally wise and behave in a rational way, but the assumption is not possible or reliable. Despite these limitations, game theory is helpful in providing solutions to some of the complex economic problems, even though as a mathematical technique, it's still in a development stage.